Okay, you ready? Okay,
Ready.
so this is the heart. You can see that this side is thicker than this side over here. So this side is the left ventricle. This is the left ventricle here. This is the left side of the heart. This is the right ventricle, and this is the right side of the heart because it's thinner. The left side has to pump blood to the rest of the body, so that's why it's stronger. Whenever you look at these string structures here, they're colored red in yours, but usually they're white. Without the dye on there. Those string structures are called chordae tendineae. That they are attached to both of your AV valves. This is the AV valve. Booty bumps. This is your valve located on the left side of the heart that has the chordae tendineae attached. So what's the name of this AV valve?
The tricuspid.
Everybody agree the tricuspid
Or the
valve? Everybody agrees the tricuspid valve is on the left side?
Left side is the bicuspid.
Bicuspid. This is the bicuspid valve.
I'm
That's
backwards.
fine.
Backwards
That's fine.
to me.
Okay, this one right here is the right side of the heart. Here are your chordae tendineae here. And you see these floppy parts right here? This right here? That's the valve. So what valve is this? If it has the chordae tendineae attached, it's going to be an AV valve, and it's your tricuspid valve. Good. Okay. So we have this part up here. This is part of your right atrium because it's above or superior to the valve. So this is the other half of the right atrium. This is the other half of the right ventricle. This is the other half of the left ventricle. This is the one part of the left atrium, and this is the other part. So actually your cut here did really well because it went through all 4 of your chambers. Okay, we want to look at, I can see that this right here is your left ventricle, and the blood's going to leave your left ventricle and go through this blood vessel right here out of the heart. This is the aorta that the probe's passing through right now. If I can get your scissors and cut it, we can see your aortic semilunar valve. Hair valve. Okay. Can I get somebody to like hold this open? Oops, sorry. Okay. So let's see if we can clean out some of this latex here. We've moved a little bit, so I don't know if you need to move your camera. Look, it's weird.
Did it get you in the face?
I think it did. Okay. So this right here is a valve. See that? It doesn't have chordae tendineae, so it tells you it's one of 2 valves. What valves are they? It's one of the semilunar valves, right?
It's the aorta.
It's the aortic semilunar valve because this is the left ventricle pushing the blood up to the aorta. When the blood goes from the aorta back to the left ventricle, this is called a pocket, or most books refer to it as a pocket. You have 3 of these, and they're all arranged in a circle. So when blood goes back down towards the left ventricle, it catches it like that right there. The pocket fills up with blood, and that will close the aortic semilunar valve. The pulmonary semilunar valve is the same exact structure. It works the same way. So whenever you have blood flowing this way, see it like clearly just, it travels smoothly. So whenever blood starts going back to your left atrium, it's going to catch it every time and open up and form a pocket to hold the blood, which closes the opening. Okay, this right here is your semilunar valve, your AV valve. With your chordae tendineae, remember your valves are floppy, right? I know this right here is latex, but it looks floppy good. It was a good example of floppy. So this right here is this is your valve here. When blood goes from your left ventricle up to your left atrium, this valve is floppy, and it's going to go towards your left atrium. But notice that, actually I have a really good picture here where the valve is trying to come up to the left atrium, but your chordae tendineae won't let it go any further. So just put a hole in it, okay? Do you see how it holds it closed instead of allowing it to open up into the atrium and allow the blood to flow here? Okay, so that's the structure of both of your AV valves with the chordae tendineae. Okay, so what I want you to look at is we'll do it. Apex is here. The interventricular septum, this is the muscle that's between the 2 ventricles. So this is the interventricular septum here. So it's made up of myocardium. That would be the other interventricular septum, or the other half of it. This is your epicardium out here.
You said it was made of what?
It's made up of myocardium. It's part of your myocardium because it has muscle in it.
Okay.
Okay, this is your epicardium, because that's the covering on the outside of the heart. It's also known as your visceral pericardium. This is your myocardium. This is your myocardium. Anything that looks brown there, like muscle. And then you can look in the chambers, and you can see that smoother, shinier lining there. That's your endocardium. The endocardium is going to make the inside of the chambers smoother, so the blood can, have less friction moving through. Okay, so we said that this is your left ventricle, and blood would be going from your left ventricle to your aorta. So on your test, the probe would look like this. The probe would be in your left ventricle, and I would say, name the blood vessel the probe's passing through. And you're supposed to be able to associate the aorta with the left ventricle and say aorta. Over here, let's see what we can do here. This is,
It's still intact right there.
this one right here. This one, it goes into your right atrium. Do you see that? That you cut directly in with this blood vessel here. I mean, you cut it in half. So the blood would actually go through this blood vessel into this chamber. So on your test, it would say name the blood vessel the blood is passing through, and you would say it goes into the right atrium. The vena cava.
Superior vena cava.
Okay, on your sheep heart, just know vena cava, but yeah, on your models you do to know superior and inferior. But if you just get vena cava on the sheep heart, that's good. Okay, this right here is your right ventricle. I don't know why I keep saying everything wrong. Whenever you have your right ventricle, a lot of times your pulmonary trunk goes to the back here. It's not a lot of times, but every time. And I can feel my finger right there. So on your test, I would have the probe passing through this way. Okay, I have the probe passing through this way, and the question would say, name the blood vessel the probe is passing through, and you would be able to say the probe's end is in the left ventricle, right ventricle. Right ventricle. And whenever it's in the right ventricle, the blood will leave the heart going to the lungs. What blood vessel takes the blood to the lungs?
Pulmonary artery.
Pulmonary artery or pulmonary trunk. Okay, so that's 3 of them. Let's look for our pulmonary veins. Pulmonary veins. Actually, I think you cut right there in between them too. Yeah. See, your pulmonary vein is right there. You have several of these, but this is the largest one. Okay. So here it would say, name the blood vessel the probe is passing through. This is going into the left atrium, and so the blood vessel that takes blood to the left atrium is the
Pulmonary
veins, because veins carry blood back towards the heart, so pulmonary veins would be that answer. Okay, so here you have your apex, your epicardium, myocardium, endocardium. This is your interventricular septum specifically. Chordae tendineae. You see this, this is a good picture here. You see how this looks like the wall of the ventricle here, and then it has this big lump right there, right? And notice on that lump you have chordae tendineae attached. That muscle right there is a papillary muscle. The papillary muscles are in the ventricles, and they're going to pull on your chordae tendineae to make sure that your chordae tendineae don't allow the valve to backflow into the atria. Okay, that's all on your heart.
Is it blue and red because it's like
Deoxygenated on your left, deoxygenated on the right side, oxygenated on the left side. Actually, if you don't mind, I try to do y'all's like real good like that so that you would share that. So if you can share that with everybody.
I will.